Hello everyone, today I'm going to solve Leetcode problem number 236, lowest common ancestor of a binary tree. Now let's read the question. Given a binary tree, find the lowest common ancestor LCA of two given nodes in the tree. So what is LCA? LCA between two nodes P and Q is the lowest node in the tree that has both P and Q as descendants, and it is allowed for a node to be a descendant of itself. So now let's look at the example problem that makes it more clear. So here, let me, yeah. So here we have P5 and Q1, right? So where is 5? So here it is 5 and here is 1, right? So here in this case the lowest common ancestor of both of these node is 3, right? Because the 5 is descendant of 3 and 1 is also descendant of 3. Here the two nodes P and Q lies on the opposite side, right? Lie on the opposite side. So yes, so 5 on the left and 1 on the right. And so now let's look at the another problem. We have a P5 and Q4, right? So let's see where, yeah, we have 5 here and 4 here, right? So um so here so the both of these node lie in the left subtree. So we won't be able to find any of two nodes in the right subtree, right? So what could be the logic here? So since there is the another definition of LCA, that if the node, I mean like the node itself is allowed to be the the node is a descendant of itself, right? So yes, here if instead of 5, if it was 3 here, 3 and 1, then the lowest common ancestor would be 3, right? So that means, so if either of P or Q is the root, then we can return the root as the ancestor, right? So yes, so that is one conditions that we one of the best case that we should actually look into. And so if not, then what we do, we traverse to the left, right, and then see if this node is either P or Q, right? So if it is one of these two nodes, then we can return it to its parent, right? And this indicates that yes, we have found the node in that path. And yes, and then we move to right and then search in the right subtree and see if this node is one of P or Q, right? And if it is true, then what we do, we return it back to this is, and we return it back to its parent node, right? So if the parent node or the parent function receives non-null, then that means that we have found the node and it should be the LCA of those two nodes, right? So yeah, that's the case. And now let's look at the second problem here. So here in this case, what we do, we have 5 and 4, right? Okay, so we first check left and then we find here the node, right? Okay, then that means we return it to 5. So the left has already written from, we have found one of the nodes from the left subtree, right? Okay, and we check into right. Here we have Q4, right? So this does not belongs to Q. So this is also not Q and this is also not Q, right? So what we get from the right subtree, we're going to receive null from the right subtree, right? because we couldn't find the node over there, right? So if either left or the right subtree becomes null, then what would be our next task? We'll have to search within this left subtree, right? Because we didn't find it in the right subtree. So it is that the another node lies within this subtree, right? So that means we will search in this subtree. So yeah, so we'll have to follow this logic. So let me clear all of this. Yeah. Yes, so now let's code. So first thing what we need to do is, first we need to check whether we have tree or not. So if the root is null, we can return null, right? Yes. What else? So yeah, if root dot val equals to p dot val, or we'll need to check the value. Root dot val equals to q val, then what are you gonna do? We're gonna return root, right? So yeah, so as I said before, so if the root is one of two nodes, then we can simply return root, right? Yes. Now what is our next task? So what we did, we checked into the left subtree separately, and then we check into right subtree separately, right? So yes, tree node the left. So yeah, so we'll have to check into the left subtree, right? So we will call the function, we will make a recursive call to the function. So yeah, root dot left, so we will go to the left, and then we send p and q as well. So yes, we first check in the left, right, and then we will do the same thing for right. Lowest common ancestor root dot right p comma q, right? Yes. So yeah, so and what we did, so for the first case, if we receive not null from both left and right, yes, so if left does not equals to null and right does not equals to null, then what we can do, we can return root, right? So yes, so here in this case we found 5 from left and 1 from right, and we return 8 to the parent. Here the root is 3, so that means we can return 3. Yes. What if like either of these is null? So if that is the case, so yeah, so what we can do is like if right is null, then we can send left as right, right? But yeah, in like if the both the right and left is null, then in any way we are going to send null, right? So yeah, that should be all right. So now let's check our code. Okay, let's submit our code here. Oh, great. So yeah, we're done.